Alright, I am going to talk about writing function rules, looking for patterns, okay? If you recall, we have wrote functions in the last video. F of x equals something like x plus 2. That's a function, okay? So we're going to be writing those rules today and just looking for patterns. So what would stage 4 look like? Here we have stage 1 has 1 flag, stage 2 has 2 flags, stage 3 has 3 flags. So what do you think stage 4 would have? 4 flags. And stage 10 would have 10 flags. So if we have an input-output table, let's call it x and y, our stage number and our number of flags. Stage 1 has 1 flag, stage 2 has 2 flags, stage 3 has 3 flags, and so on. Okay, so if you keep that going, keeps going. Each y value basically equals the x value. So when we write an equation, you can write that as y equals x, or in function notation, f of x equals x. That just tells you y equals x. Okay, the second example here, one butterfly takes 7 blocks, 1, 2, 3, 4, 5, 6, 7. So 2 butterflies, 7 and 7, would take 14 blocks. 3 butterflies take 7, 7, and 7 is 21 blocks. So how many blocks for 4 butterflies? 7 times 4 is 28. 10 butterflies, 10 times 7 is 70. So your input-output table, x, which is our number of butterflies, and y, which is our number of blocks, 1 butterfly is 7 blocks, 2 butterflies is 14 blocks, 3 butterflies is 21, 4 butterflies is 28, and so on. So our equation there, what did you do each time? We took our x value and multiplied it times 7. So y equals 7x, or f of x equals 7x. Okay, so there are 2 examples right there. Here's a third. Patty the plant starts out with 5 leaves after 1 month. After 2 months, she has 6 leaves. 3 months, 7 leaves. 4 months, the plant has 8 leaves. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So after 5 months, what are you doing each time? You're adding 1. So that would be 9. And then after 6 months, it would be 10. So write an equation. Well, what are we doing each time here? We're adding 1. Basically, when you write these equations, it's y equals, this is going to be our common, what's called our common difference. Or we can call that our change in y value for each x value. Okay, so our change in y value times x, all right, that's your common difference, times x, plus, and then this number right here, this is what's called our 0 number. That's where we start, our initial value. So not after 1 month, but where did you start at 0 months? Well, if this kept the same pattern, that would have been 4, because 4 plus 1 is 5. All right, so when you do this, you have y equals, your common difference here is 1, because you add 1 each time, so 1x, plus the 0 number happened to be 4. So y equals x plus 4. Or again, you could write that f of x equals x plus 4. Okay, so let's look at some more with tables. Now again, we have y equals our common difference times x plus what we call our 0 number. So here, inputs are 0, 1, 2, 3, 4, so those go up by 1s. This right here, 2 to 3 is plus 1, 3 to 4 plus 1, 4 to 5 plus 1. So that's our common difference. So we have y equals 1x, or just x. And then our 0 number, that's actually given to us. Input of 0, output of 2, so that's going to be plus 2. So here, f of x equals x plus 2, or 1x if you want to write the 1 in, but you do not need to. Okay, the second one, we have function rule of 0, output of 0, input of 2, output of 1, input of 4, output of 2. Sometimes you can just look at that and say, each output is half of the input. So what does that mean? Well, wouldn't it be y equals 1/2 x? Yeah. If you can just look at it and figure it out, what you want to think about is there would be some numbers in here, right? So 0 to 1, And then 1 to 2 goes from 0 to 1 on the output, so that really would be 1/2. Okay, and then 3 would be 1.5. So that actually goes up by 1/2. So our common difference is 1/2 times x, and then our 0 number, that is 0, so plus 0. So that is just f of x equals 1/2 x. Okay, so sometimes they are simple like that you can figure out, but if you don't, we have a method to do that. Okay, now if we are already given a function, can you fill in the table? So what does that mean? We have this function, f of x equals -2x plus 8. Use the values 1, 2, 3, and 4 as your domain. Remember, domain is your x values. So there's your 1, 2, 3, and 4. And then graph. So to fill in the table, if we know that f of x equals -2x plus 8, and our x is 1, so f of 1, -2 times 1 plus 8. That's -2 plus 8, which is 6. Then we have f of 2, -2 times 1, -2 times 2 this time is -4, plus 8 is 4. And then f of 3 is -2 times 3, plus 8. -6 plus 8 is 2. And then f of 4, -2 times 4 is -8, plus 8 is 0. So we have 1, 3, 6, 2, 4, 3, 2, 4, 0. So our graph looks like this. And yes, you should label these. I didn't, but you should get in the habit of doing that. Okay. Make an input-output table for the function. All right, this one's a little different because it has a fraction. So let's look at that. Now it says 6, 9, 12, and 15 as your input. So 6, 9, 12, and 15. So f of 6 would be 2/3 times 6 minus 5. 3 goes into 6 twice. 2 times 2 is 4. Minus 5 is -1. F of 9, 2/3 times 9 minus 5. So 3 goes into 9 3 times. 2 times 3 is 6. Minus 5 is 1. F of 12, 2/3 times 12 minus 5. 3 goes into 12 4 times. 2 times 4 is 8. Minus 5 is 3. And then f of 15, you have 2/3 times 15. 3 goes into 15 5 times. 2 times 5 is 10. Minus 5 is 5. So now we need to extend this because we need a -1 here. Okay, and then over here, let me go over, make that 3, 6, 9, 12, and 15. So we have 6 is -1, 9 is +1, 12 is 3, 15 is 5. So one thing I want to stress here, it doesn't matter what you make your scale, just make sure it's uniform width. Okay, I wouldn't just start here with 6, 9, 12, and 15 like that. You need to make sure they're all uniform. So the first 2 blocks is 3, the next 2 blocks is 3, the next 2 blocks is 3, and so on. Okay, now here are some U-try problems. Go ahead, pause this, try the U-try problems, and we will go over them in the next class. Now, this topic 7 part 2 is a little long. I'm going to stop the video here and start up and actually add topic 7 part 2B. Okay, have a good day.